this is like a technicality. So let's in this one, just it's a well-known thing with well-known solutions, trigonometric substitutions for integrals. So let's ask for an example. That would be nice, just for illustration. We're not gonna explore everything about it, but it's gonna explain some stuff. So let's ask chat a bit about it. Give explained example of integral solution using rate sum. So this is a well-known technique for solving integrals. So what we have, for example, such an integral 1 over square root of 9 minus x squared, and it matches a pattern a squared minus x squared inside a square root in the denominator. That's yeah. So for this form we use substitution. X is a times sine theta, so we introduce a new theta there, and then a is 3, so let x be 3 sine theta. So then we compute the differential dx using differentiation of both sides, derivative of both sides, and then substitute into the integral. We replace everything in terms of theta, and then we get to this sort of thing, and that's useful for us because we can, this is square root 3 and this, well, oh, you can rewrite 1 minus sine squared as cosine squared. So we actually get 3 cosine theta of the new theta, and we plug it into the integral like this, and things kind of cancel out, and then we just get a linear function in terms of theta. But then we have to convert it to the x, so we would have 3 sine theta, and oh, we find what theta is. It's arc sine of x over 3. So this will be, I think, a repeatable pattern. It will be like always arc sine of x over a inserted in these examples of exactly this form. But there's more forms, of course. That's why this example doesn't cover all cases. But so then we get this result. So that's quite neat. And the idea recap. Well, a squared minus x squared in the square root. Then we have a sine theta, so we find this theta, we use this theta there. A squared plus x squared, it will be tangent theta, and x squared minus a squared, so if it switch, it's secant theta. So we see these patterns. There can be more examples on this.